In the name of Allah, the most beneficent and most merciful. Assalamu alaikum viewers. My name is Iram Jabal. I would like to welcome you in chemistry class. In our today's lecture, we will discuss about Group 4A elements. First of all, we will discuss the elements which are present in Group 4A. Group 4A consists of carbon, silicon, germanium, stainless and lead. There are 5 elements in Group 4A. These elements are called 4A because they all contain 4 electrons in their valence shell. For this purpose, we will discuss about electronic configuration of Group 4A elements. From periodic table, we can easily understand the electronic configuration of an element. From the period number of an element, we come to know about the valence shell. As you can see, carbon belongs to second period, so its valence shell is 2, and carbon belongs to group 4A, so carbon contain 4 valence electron which are present in 2s2 2p2. Same is the case with silicon. Silicon belongs to third period, so its valence shell is 3 and again belong to group 4A, so this valence shell contain 4 electrons present in 3s2 3p2. Same is the case with germanium, stainless and lead. They belong to group period 4, 5 and 6, which represent valence shell, and group 4A, so they contain valence electrons present in 4s2 4p2, 5s2 5p2, 6s2 6p2 respectively. Now we will discuss properties of group 4A elements. The reason elements placed in group 4A. First reason is that they all contain 4 electrons. That's why they are placed in group 4A. But there are a very marked change in properties when we move from carbon to lead, despite of similarities. As you know, carbon is a non-metal, so it forms acidic oxide, carbon dioxide, which on dissolving in water form acid, carbonic acid. Same is the case with silicon. It also forms acidic oxide and acid in water, which is salicylic acid. But oxides of germanium, stainless and lead are amphoteric in nature. In the same way, carbon and silicon form long chain compounds, as you are familiar with hydrocarbons, in which carbon form long chain compound. In the same way, silicon also form long chain compounds. As you can see in this structure, silicon oxygen silicon linkage extend and we obtain a giant molecule known as silicon dioxide or sand. Now we will discuss common properties. First common property is that they all contain 4 valence electron, so their valency is 4. In the same way, they form hydride like CH4. they form halides like CCl4, and they form dioxide like CO2, PbO2, etc. And as I already told you that from moving carbon to lead, there are very marked changes. This marked change is observed in binding with other elements also. In some cases, stannous and lead use 4 electrons for binding purposes, and in some cases, these two elements, stannous and lead, use 2 electrons for binding purposes, and 2 electrons act as inert pair. Inert pair is that which is not involved in bond formation. This pair is inert pair, and this inert pair effect on properties of compound, so its effect is known as inert pair effect. Inert pair effect can be seen in case of PbCl2, in which 2 electrons are used for binding and to act as inert pair, and in SnCl2, in which also 2 electrons used for binding and 2 electrons again act as inert pair. These two compounds shows inert pair effect. Now we will discuss about occurrence of carbon and silicon. Carbon is a abundant element, and carbon exists in two forms, crystalline form and amorphous form. You already know these two terms. Crystalline form have regular arrangement of atoms, ions and molecules. In crystalline form, carbon exists in form of diamond and graphite. In amorphous form, there is a disorderedness in the arrangement of atoms. When carbon arranged in disorderedness way, then it can be seen in form of coal and charcoal. In the same way, silicon form 25% of earth crust because silicon exists as silicon dioxide, which are commonly known as sand. And silicon not found in free state, which I told you in next lecture why this silicon not exist in free state. Silicon is a major constituent of rocks in form of silica and silicates. Silicon exists with most of the minerals or except the ores which contain sulfide, sulfate, phosphate and carbonate. Beside these ores which contain these elements, silicon exists in form of silica. In the same way, silica also form quartz, which are used as a precious stones like rock crystal, amethyst quartz, smoky quartz, rose quartz and milky quartz. These stones have different colors, like some have grey color, blue, purple, pink, etc. These different stones are used in making jewelry articles. In the same way, opal is a hydrated variety of quartz. Now we will discuss about peculiar behavior of carbon. As you know that every first member of a group always have some different properties with the rest of elements of a group, because first element is smaller in size than rest of the elements. Due to its smaller size, every first member have some unique characters. In the same way, carbon also have some unique properties. Carbon is a non-metal, silicon is a semi-metal, while the other members of group 4A are metals. In the same way, carbon form a long chain compounds. These long chain compounds are known as hydrocarbon, and these hydrocarbon constitute organic chemistry. Organic chemistry originate due to self-linkage property of carbon atom. Carbon, in order to satisfy valency, carbon form carbon to carbon linkage. This carbon to carbon linkage is known as catenation, and this catenation form a variety of hydrocarbons which we will discuss in organic chemistry also. Now we will discuss about oxides of carbon. There are three oxides of carbon: carbon dioxide, carbon monoxide, and carbon suboxide. In this lecture, we will discuss only two oxides, carbon dioxide and carbon monoxide. First of all, we will discuss about carbon monoxide. Carbon monoxide is a diatomic molecule. This diatomic molecule have a triple bond between carbon and oxygen atom. These two atoms have triple bond just to satisfy valency of atoms. Carbon monoxide is a slightly polar molecule. This polarity can be seen from this structure also. Carbon contain 4 electrons in valence shell, which are represented by a red cross over here. Oxygen contain 6 electrons, which are represented with blue dots in this structure. And every element form bond with other elements just to stabilize themselves to complete its octet. In order to complete octet, oxygen donate its lone pair to carbon atom and form coordinate covalent bond, while other electrons form covalent bond by mutual sharing of electrons. In this way, in structure of carbon monoxide, there are three bonds. Two are covalent bond formed by mutual sharing, and the other one is coordinate covalent bond, which is formed when oxygen donates its lone pair to carbon atom. Due to this donation, there is polarity in this molecule, and this polarity is not cancelled out over here. Due to this non-cancellation of polarity, carbon monoxide have a dipole moment of 0.12 dBi. Now we will discuss structure of carbon dioxide. Carbon dioxide exists in gaseous state as a linear molecule, and its observed bond distance is 115 picometer, and when carbon dioxide is in solid form, then it have face-centered cubic structure. Due to the linear structure of carbon dioxide, its dipole moment is 0 because in linear structure polarity is cancelled out. As you can see in this structure, carbon form double bond with each oxygen atom by sharing of electrons, and a linear structure is obtained. It's all about today's lecture. Thank you. Allah Hafiz.